Hello guys, today we'll learn the effect of coexisting anions, or we can say counter ions, or we can say electrolyte ions on the removal of the pollutant using a certain kind, or we can say a specific kind of adsorbent. Basically these coexisting anions like chloride, nitrate, sulfate, carbonate, phosphate, or you can say other ions in the water, basically they compete with the pollutant for active adsorption sites, and they significantly lessen the pollutant recital by the specific kind of adsorbent. And these coexisting anions have been reported to form a certain, can say, complexes, and certain studies you will find inner sphere complexes with the pollutant, and they basically diminish the collaboration between the two anions. So the effects tend to be significant with sometimes with the change in pH, and also sometimes with the increase of the anions concentration. For example, in some of the studies we see that the chloride and nitrate ions, they do not have visible effects on the adsorption of the pollutants, but like other spheres or other complexes like carbonate or sulfate, they have a kind of some significant effect on the adsorption of the pollutant when these anions are being present with the adsorbent in the water. Now when the ionic concentration increases, so these lead to a decrease in the adsorption, and basically there is an increase due to competition of our adsorption site, and these ions basically form the inner sphere complexes that are straightly synchronized with the surface groups, and may not compete or compete at lower, when they are in lower ratios, they don't compete with electrolyte ions. So the adsorption is less affected by changing the ionic concentration. In many cases of inner sphere complex formation, the adsorption increases with increasing electrolyte concentration. So this effect is usually attributed to changes in the electric potential in the interface, whereby the electrostatic repulsion between the charged surfaces and the anion is decreased and the adsorption is favored. Now in our today's demonstration, we will be seeing the effect of NaCl and effect of sodium carbonate, or you can say chloride and carbonate ions on the removal of the dye using the modified pozzolana. Shortly we will see how we do the experimentation in the lab. For finding out the effect of ions on the adsorption capacity of the pollutant using a specific kind of adsorbent, what we have to do, we have to first of all, here I would weigh the equal amount of adsorbent in all the vials. Here the dosage is fixed, the pH is fixed, and the concentration of the pollutant is fixed. I will be transferring around 5 milligram in all the vials. This is my pozzolana, modified pozzolana, and then here this will be our control sample. Let's start with the weighing first. Now the next step is we would add our pollutant, which is methylene blue. So we would be adding around 30 ml of the pollutant, and there is a minor correction here. I added around 20 milligram of the adsorbent in all the vials. We have 8 vials, so in each vial we will be adding around 30 ml of the pollutant, plus we would be adding, here is our freshly prepared 0.1 normal Na2CO3, and this is 0.1 normal NaCl. So what I would do, I would be adding in the first vial around 5 ml, and then I would increase the amount of the ions. So in the first set I would add NaCl, in the second set we would add sodium carbonate. Now the ions can be added in terms of weight, in terms of percentage, in terms of normality or molarity. Well, here I'm adding in terms of, this is the fixed strength I have prepared, and then I would be adding in terms of the volume. So let's start adding. Now after transferring all the diluent in all the vials in increasing order, and this vial is basically my control, just with adsorbent, no ions here. This is ion free, and this one is just the my pollutant with no adsorbent and no ions. We have total 10. We'll be transferring here and then we'll run for around 1 hour, and then we'll 1 to 2 hours, then we will check the final concentration. We are shaking for around 272 rpm, then we would start running. Let's wait for 1 hour and then we will find out the final concentration. Now after 1 hour running, this is our samples. We will centrifuge and then we will measure the concentration of methylene blue using the visible spectrophotometer. Now we are checking the concentration of the control sample without adsorbent, so which is 25.26 after dilution. So this is around 50 ppm. Now the concentration of sample with adsorbent is around 21.78, which is 40 ppm. So just dropped 2 times. Now this is the concentration of the first sample at 1 ml of the 0.1 normal NaCl. This is showing around around 50 ppm. Intensity for the second sample, which is showing a bit high. So let us check for all and then we can show you the last one. Simultaneously for the last sample, showing around 25.39. This one shows the declining trend for the removal of the methylene blue. It shows a fierce competition due to the presence of NaCl. Now let us check for the sodium carbonate. Now this is the case for the sodium carbonate. You can see it shows more fierce competition as compared to the sodium chloride, maybe because of the molecular radius of the carbonate as compared to the chloride might be more. So now let us check for all. Now let us check for the last sample. Last sample shows around 26 ppm. Shows that the presence of the sodium carbonate has more pronounced effect as compared to the sodium chloride. So we can conclude that the effect of ions have a pronounced effect in terms of percentage removal as well as the adsorption capacity. This was all about the effect of ions.